Whatever negative feedback, outrage, and backlash Intel is facing right now, they deserve mostly all of it. I'm not sure if they even have any product managers still working at the company who would have foreseen this and raised some alarms to the major decision makers, but perhaps they were let go in the midst of the thousands who were laid off. And at the end of the day, this decision came down to an executive who got pressured by investors to hit the launch button. Because this launch didn't just go wrong in one or two ways. It's been disastrous in various fronts, from inconsistent and poor performance issues, software bugs, instability problems, and reports of poor silicon quality, on top of what is effectively a paper launch in many regions. It's clear that Arrow Lake needed more time to bake in the oven. Let's discuss that in this video. Hey, if you enjoy content like this, drop a like, make sure to subscribe, and smash that bell so you never miss another video. Hey, what is going on, guys? Danny here. Welcome back to the channel, and I hope you've all been doing well. Over this past week, the internet has seen a flood of information from various tech outlets and independent reviewers who got to test Intel's Arrow Lake or Core Ultra 200S series processors for the desktop. Overall, the reception has been quite poor, with a lot of reviewers having a verdict stating that you should just buy something else, and for the most part, they are right. There are plenty of other alternatives on the market that are going to be much more cost effective and are battle tested at this stage, which will be going more into later on in this video. When I was looking at the reviews, what became really obvious to me was that clearly Intel rushed Arrow Lake to the market and it needed more time to bake in the oven so that they could iron out kinks and bugs. Now, I just wanted to take a few steps back and go back to when Intel had unveiled the Core Ultra 200S series. They had streamed the initial announcement on their Intel Technology YouTube channel, where they went over information like specs, the new design highlights, advantages, as well as briefly talk about gaming performance. In that video, Robert Halleck said the following.
And we see that Arrow and Raptor are plus or minus 3% most of the time, parity most of the time. The left end of the curve predominantly reflects the difference in the topology from Arrow to Raptor. Remember, Raptor was monolithic, Arrow is disaggregated, so there's a little latency involved. And the right end of the curve is the benefit of the reorganization of the chip. These games are more sensitive to thermal performance, electrical performance, core performance, so we get upside from those. And so net, Arrow Lake and Raptor Lake, they have puts and takes in both directions, but they are functionally the same gaming performance, with Arrow, as you can see, pushing to much lower power levels. So Age of Mythology, for example, down 136 watts at the system. Arrow represents a reset on our desktop roadmap to give us significant thermal and electrical runway headed into the future. That's performance headroom that we can grow into with future architectures, and that's one of the reasons why we've been on such a quest to re-architect these cores.
So in that clip, Robert doesn't never state how these new processors would be the best gaming processors on the market or how they would destroy the previous generation by a mile. He clearly does mention how this is going to be where Intel resets and re-architects their cores for more headroom so that it sets them up to take advantage of it with more performance with future iterations. He did also highlight how Arrow Lake and Raptor Lake are on par with each other when it comes to gaming performance according to their own in-house testing. Give or take depending on the title, but the main advantage that Arrow Lake has is better power efficiency, which should also lead to better thermals. Therefore, when I saw some of the reception from people within this community, it really came off as if they had expected a drastic performance increase when Intel themselves had stated that this isn't what Arrow Lake will be offering to consumers. I don't think anyone should have expected the 285K to be chart-topping in every gamer scenario. With that being said, though, I can still see why there was disappointment overall, and that was primarily because the performance, as far as I could see from viewing multiple reviews on YouTube and reading articles, it was just all over the place. It wasn't consistent at all, and in games where you'd expect the Core Ultra 200 series to be doing well in, or at least keeping up with the competition, they just seem to fall flat on its face. For example, in Intel's own marketing slides, you'll see how they have the Core Ultra 9 285K and the i9 14900K on par with each other in a game like Cyberpunk 2077. However, almost all reviews I saw showed the 285K losing considerably to the 14900K. In Tech PowerUp's review data, they show the 14900K is about 11% faster than the 285K at 1080p, making it on par with Alder Lake from 2021. Now, which area of the game you test in, or if you use the built-in benchmark, can certainly affect your results and the outcome. I find the built-in benchmark is fine for testing GPU performance, but for CPU performance, there are much better areas like Corpo Plaza. Steve from Hardware Unboxed in their review tested a more CPU demanding area in Dogtown and found some atrocious results for the Arrow Lake CPUs, coming in dead last. Computer Base in their review also found the same thing, where Arrow Lake was more so on par with Alder Lake and Zen 3D, where you'd really expect it to be on par with Raptor Lake at the very least.
Came to the recent round of Zen 5 reviews was the inconsistent benchmark results, namely the gaming benchmark results. Some of these reasons include just testing different games. But even in the examples where the game list overlapped, results can still differ due to how the game is being tested. And I don't just mean the quality settings used, but also in-game testing versus built-in benchmarks. Anyway, as you can see, the 285K was actually up to 5% faster when testing at the start of the game. And once we finished the downhill pass, both finished with roughly the same frame rate. And this is because we're mostly GPU limited in this test, as the CPU load is quite light. But if we jump further into the game where I do all my testing, we see that the CPU load has increased, and although the percentage isn't huge, remember these CPUs have loads of E-cores that are doing nothing during this test, so that is to say they're largely sitting idle. Not only has the frame rate dropped considerably for both configurations, but the 285K's performance has tanked, dropping well below 100 FPS at the start of our test, making it a little over 20% slower than the 14900K.
But there were titles that showed the Ultra 200 series in a good light. For example, Computer Base in their review had the new CPUs performing on par with the 7800X3D and Horizon Forbidden West. And I know it doesn't sound exciting to say that considering that's a last gen part, but again, I want to emphasize that Intel never touted there would be drastic gains over the current generation parts to begin with. Hardware Unboxed showed chart-topping performance for the 285K and Starfield, but you do have to consider that this game does better with Intel generally, and the 14900K was trailing right behind it. But more often than not, the results that were being shown had the Core Ultra 200 series in the middle of the pack, such as like this one from GN, who showed the 285K trailing behind the Raptor Lake and AMD X3D parts in Dragon's Dogma 2, which is a pretty CPU-bound game to begin with, but that argument could also be used for the AMD 9000 series, which we did also call out when that series came out a few months ago. 2024 just seems to be the year of disappointing CPU launches, but I digress. Now, the level of performance being shown here isn't terrible. If you didn't watch or read any reviews and just looked at the comment sections or feedback off of places like Reddit or the YouTube comment section, it would lead you to believe that these CPUs were performing like complete trash or the experience was unplayable. But that's not the case at all based on what we just saw. And what I'm always urging you guys to do is to look at as many reviews as possible, because there are just so many variables involved that results can vary depending the way their test benches are set up, which version of Windows was being used, game settings, which section of the game is tested, and more. It's always good to see benchmarks and results from various sources and then aggregate them for yourself on what applies mostly to you. This is something I can't stress enough, and I mean, at the end of the day, it's for your benefit. When I was watching GN's review and we're looking at their gaming benchmarks, I saw how in their Warhammer 3 benchmarks, their Intel results had atrociously bad lows, and they do acknowledge that in the review, but there is a fix for that which was posted online in their forums and in the game subreddit, and I even made a video about that a while ago, which talks about how you add a file in the user configuration folder, and that will address the poor 1% lows, and I showed the benchmarks and the results were drastically better. This isn't me knocking on the results or anything, because at the end of the day, it really is up to the game devs to fix this problem, but since I had the fix applied, and if I was comparing the two CPUs in my results, I'd have seen much better lows. And you guys will see how this ties into our next area of discussion, which is why the results have been so inconsistent and all over the place. Some of the reviewers had included memory performance and latency benchmarks. One popular one that a lot of people like to use is IDA64's cache and memory benchmark tool, as this tool allows one to see how much bandwidth their system, and more specifically the memory in their system, can push, as well as measure latency. And what I saw was that the memory latency on the Core Ultra 200 CPUs, like the 285K, was horrendous. This was also one of the reasons why results varied so much from reviewer to reviewer. Tech PowerUp in their review used a pretty standard 6000 megatransfers kit. I guess just to be fair, but personally I would have gone with something higher, as consumers can take advantage of much faster memory on Intel, and that will show it in the best case scenario, but the memory latency they showed was at 88 nanoseconds, which is horrendous. Like, we knew that with Arrow Lake's new tile design and the fact that they were removing the memory controller or the IMC off of the compute die, that there would be a latency penalty to that, but I didn't think it'd be that large. Leo from Kit Guru, who was also using a much faster 8200 8200 mega transfers kit saw the same latency, although he did note memory bandwidth was much higher. However, I think it should be higher than that, and I'll get to that in a second. Computer Base had also used that 8200 mega transfers kit, and they saw memory latency was lower at 78.9 nanoseconds, but they were using an ASUS Z890 board, whereas Kit Guru had used the MSI board from their reviewer's kit. And from my experience, ASUS boards tend to apply tighter auto timings, whereas MSI boards tend to be much more looser, so that definitely played a role. I could make a whole separate video on memory configurations because there's so much that comes into play there, and I do also believe it did contribute to those who were facing stability problems. This is why I personally like to intervene and make my own manual adjustments, because even with some lazy tuning, you can significantly increase not just memory bandwidth, but also lower latency. For example, on Computer Base's screenshot, their memory bandwidth looks alright at first, but here's my 14900K on slower 8000 memory with significantly higher bandwidth. But I also use a slower kit that's on my test bench at 7600 mega transfers, and my bandwidth is still high and latency is also really low compared to what most reviewers were showing out of the box. Again, not a knock against them, especially when they're strapped for time at get samples like 2 or 3 days before when the embargo lifted, but you do also have to know that there is performance being left on the table there. But circling back to Arrow Lake, the latency penalty that Intel have incurred here is quite drastic. This is basically as bad as Zen 1, if not worse. This is definitely playing a large role in holding back the performance of these chips. If anything, Arrow Lake is an architecture that I can see benefiting a lot from a 3D cache solution. The other thing that I've been hearing reports about is that the Windows scheduler hasn't been working correctly with Arrow Lake. Some users have been reporting that turning off eCores has resulted in some games seeing better performance. Some users stated that just simply testing with the default Windows power plan was hurting performance, and it wasn't until they used the high or the hidden ultimate performance plan where they saw an increase in performance.
And then I ran 3D Mark TimeSpy, and the score I got was utterly atrocious. The problem specifically looked to be the graphics side of things. I had the latest Nvidia driver installed. I did not have a clue what was going on. What I found was, flicking around inside the Windows power plan, I went from balanced to high performance, and suddenly the performance was fixed.
There were users suggesting that different builds of Windows 11 24H2 were resulting in performance discrepancies, so you guys can see how there are just tons and tons of variables at play here that affect performance. I think that's also one of the reasons why Intel was pushing reviewers to use APO, which is their application optimizer that works in tandem with the scheduler or thread director to tackle these problems so that thread management is efficiently handled. CapFrameX on Twitter, who has been posting their findings, saw performance in some cases improves when disabling some clusters of the E cores and a couple of P cores. You can see what they mean from this diagram, and then the results do reflect that. Clearly, the scheduler isn't intelligently scheduling tasks on the right threads. Tech Power Up in their review noted how they saw like a difference of around 50%, I believe, when comparing 24H2 to 23H2 in favor of the latter. So now we're getting into that conversation of tuning and manual overclocking. Tuning is great, and as I was saying from my previous video, these CPUs look like they're really in desperate need of users to get into the nitty-gritty and apply their own tweaks and settings as opposed to out of the box to really help the CPU stretch its legs and boost performance. I really liked Derbauer's review because he does go over the different aspects of overclocking the P cores, the ring, D2D clock, and also found that just by adjusting those, the 285K was providing considerably better performance when compared to stock. I did see a Reddit thread on the R hardware subreddit where someone had referenced a review from China that was posted to Bilibili, which is basically their YouTube, and saw that performance on the 285K was actually better when disabling all but one P cores and overclocking all the E cores to 5.2 GHz. And that surprised me. I think because E cores over the past few years have gotten quite a bit of a bad rep, some people end up overlooking them and their capabilities, but apparently these new E cores, they can be overclocked and pushed pretty far. Like 5.2 GHz on E-cores, that's pretty wild if you ask me. This is why I've actually been itching to get my hands on a 285K to see what I can do with it and what kind of performance can be attained after doing a whole bunch of manual tweaks and tuning and overclocking. But apparently the launch has been a paper launch in many regions, including Canada. I talked to some of the retailers here and they told me that they haven't even received any 285Ks and that a very small amount in the single digits have been allocated for their inventory. But circling back to the whole tuning and overclocking overclocking subject. Yeah, it's great, and I realize that sometimes I will get ahead of myself when we discuss these things, but in the grand scheme of things, how much does that matter? Because even with the help of tuning like in Derbauer's review, the 285K was still sometimes trailing behind the 14900KS and or the 7800X3D. When most people would just press XMP and forget about it, it's hard to use this as an argument or a selling feature. Sure, it gets me excited, but for most people, this is why a chip like the 7800X3D or the upcoming 9800X3D are so appealing. Because with those chips, you barely have to do anything. And I mean, sure, you can still tune, adjust your RAM, still apply tweaks to the curve optimizer, but even if you don't, your performance out of the box is still stellar. A good takeaway from this, and this is for Intel especially, is that you can't expect your users to be faffing around with different Windows installs, different power plans, different power settings, turning off E-cores just to get most optimal performance. It just doesn't work like that. And I think that APO is really a band-aid solution, so they really need to hammer this down and get something that works correctly out of the box. Like if you need to get 9,000 megatransfers CU-DIMM kits that cost like $400 or $500 just to get that latency down to what a tuned Raptor Lake CPU can do using 7400 or 7600 A-die or M-die kits that cost less than half, then forget it. People are not going to be running to buy these CPUs, except for maybe the hardware XOC nerds. And speaking of prices, if Intel have highlighted that with Arrow Lake, they have essentially undergone a reset and they knew that performance overall wasn't going to be better than last generation, and in most cases it loses, then they should have priced them appropriately. At $630 using Newegg's pricing, I just can't see the reason to buy this over a 13900KF from Amazon, which retails for like $384, or you can buy a 14700KF for about $330. Right now, these last gen Intel parts are offering some really good value, even over AMD, and I get it, people have been deterred due to all of the instability and degradation issues that lots of folks have faced over the past year, but there's new BIOS updates that have come out and address those issues, and or you can just manually adjust your LLC. Furthermore, the prices on many of these new Z890 motherboards are significantly higher compared to the Z790 counterparts. On Z790, you can find a decent motherboard for around $200, and that'll give you plenty of great features, and I get it, Z890 has more features and upgraded lanes and all of that, but you're also looking at paying $100 to $200 more, so you got to decide if that really justifies it. Even for the top end boards, which people are accustomed to seeing a premium on, have had some ridiculous markups compared to last generation. And what really justifies these high prices? Like, I get it, Intel has built these new CPUs on TSMC's 3 nanometers, and so they probably don't have the margins to really price these CPUs as low as they can. But when you have a product that doesn't outperform the last generation by a significant amount, that is going to be deterring a lot of people. What is also a huge turnoff is the fact that many reviewers had reported instability problems with their CPUs and motherboards. Hardware Unboxed noted that they had stability problems with games crashing, blue screens. Leo from Kid Guru showed on their review how they just simply tried to install Windows and that was giving them problems. Brian from Tech Yes City had noted similar problems with game crashes and weird hitches within the operating system, such as with their mouse skipping. At this stage, it's almost expected that when a new platform and new microarchitecture launch, that there will be teething issues. But if you're expecting people to pay premiums to become beta testers, then yeah, you can go pound sand at that point. And sadly, the benefits of this platform, which were mainly better thermals and power efficiency, do not really outweigh the cons. And I know I didn't really go over productivity performance or AI performance, which I think they are doing much better in. My audience really just cares about gaming for performance, so that's what I focused on. But even when I was looking at those benchmarks, I wasn't blown away. There really isn't any sort of scenario where Arrow Lake was blowing everything out of the water. I just didn't see that. And to the point of power efficiency, sure, compared to 14th gen, it's more power efficient, but when you compare it to AMD, they're still losing in that category, and in some instances, it's not even close. GN in their review had some good charts deep diving into the power efficiency topic, and the reality is that compared to something like an X3D, or even last gen, it's just not more efficient. And those savings in power efficiency are also diminished by the difference you'd have to pay for the new CPU anyway. Because remember, like I said, a lot of the reviewers were showing out of the box numbers, you can actually just get the 13900KF, apply an undervolt, power limit it, and you effectively have the same performance per watt. So I don't really see any benefits of the Arrow Lake processors in that regard. And remember, TSMC is 3 nanometers, and this is all that they were able to come up with. That is quite shameful. With all that taken into account, even if you did want to buy a 285 or 265K, the CPUs in many regions, as I said before, are just very difficult to find, with many stating that this was just a paper launch. Like I said, here in Canada, most if not all of the retailers don't have stock at all. In the UK, a buddy of mine was telling me that their retailers have said the same. I even heard that even in the States, where that's usually the best case scenario when it comes to inventory, people are having trouble finding them. And what also corroborates with this report is that apparently Intel is having manufacturing problems and is getting bad batches for the 200 series, and people are finding instances of instability not related to software but because of silicon quality. Kobite7Kimi, who's a known hardware leaker on Twitter, was talking about this, and he said that he received messages about manufacturing problems and quality control. Could it be that they're having problems with this new node? Maybe the yields they are getting simply can't attain the advertised boost clocks? If there's more to this report, we will probably find out over the passing weeks and months. There is also another major reason why people are deterred. It's a rumor, but apparently with this platform, Intel will only support one generation on Z890. Imagine releasing a whole new platform and then the series you launch turns out to be completely mid, and then that's it. At this stage, you're just doing free marketing for AMD because your competitor is supporting multiple generations on one socket like they did with AM4, and yet here you are learning absolutely nothing. But I hope for Intel's sake these rumors are false and that there will be a better and more refined generation coming after this one, because from the looks of it, they have just set up Arrow Lake to flop or fail, and they could really use a better successor in the future. Looking at Arrow Lake, it's clear that these processors needed more time to refine. Rushed design changes, unrefined memory latency issues, and scheduler mishandling have collectively hurt performance, as seen in inconsistent results across benchmarks. These are all the signs that Arrow Lake, in many ways, feels like a first draft that's been rushed to meet deadlines rather than a polished release. This isn't to say that the architecture lacks potential. Intel's tile design and efficiency improvements could pay off in future iterations, but this generation isn't quite ready for prime time. Hence, you have seen many comments stating, why did Intel even bother with this release? Another critical point is Intel's recent shift in focus towards AI and data centers, which has raised concerns that the company may be sidelining their consumer products like desktop CPUs. With the Core Ultra series, Intel seems to be aiming at power efficiency over raw performance, a direction that fits well with server environments and AI applications. However, for general consumers, gamers, and DIY enthusiasts, this shift is concerning. It brings up questions about Intel's long-term strategy in the desktop market, particularly when AMD is doubling down on high performance, better efficiency parts with options like 3D V-Cache for better gaming performance, better performance per watt. An Intel version of 3D V-Cache or even a P-Core only model could be game changers, but there's been no solid indication that Intel may be interested in this, that there's anything on the roadmap anytime soon. As Intel heads into the next generation, it will be interesting to see whether they recognize and address these concerns. Their competition has made many strides with high performance, cost-effective options, leaving Intel at a serious disadvantage unless they can course correct. Ultimately, Intel needs a refined, consumer-focused roadmap to stay competitive and continue appealing to gamers and DIY users who want out-of-the-box performance without heavy tuning or complex optimizations if they don't have to. It is absolutely crucial that they hammer this down, considering how poorly the company has been doing lately in internal management, appeasing investors, and handling their own logistics. In summary, the Arrow Lake launch highlights a transition period for Intel. While their focus on efficiency might pay off in other sectors, for the DIY market, it's hard to recommend these chips as they stand. If Intel can listen to consumer feedback and address these issues, there's a lot of potential here, but for now, gamers and power users may find better value and performance elsewhere, such as with last generation parts or with Team Red. Alrighty guys, so that's going to be doing it for this one. We'll be touching base in the next video. If you guys found this video to be informative and entertaining, then leave a like. Let me know your thoughts and comments down below. Be sure to check out the video description for cool links and ways to support the channel, such as using my Amazon affiliate link. And if you're interested in seeing more content like this, then consider subscribing. I'd greatly appreciate it. Thank you guys so much for watching, take care, and I'll see you in the next one.